Welcome back to Hard Maths with Kevin. This is the second part of our conjoint analysis study. So if you haven't watched the first part, go back and check that out now, where we set up the conjoint and talk about the various attributes and what we're going to be trying to figure out here. But if you have watched that, we'll dive right in. So Kevin, what can you tell me about my bicycle
your bike preferences? So let me remind everyone that we set up a conjoint in the last video. We had 6 attributes: price, composition, brand, shifting, weight, and riding experiences. And each attribute had a differing number of levels. So price went from 1,000 to 12,000. Composition was steel, titanium, carbon fiber, etc. And so I had Drew take this 20 times in order to get some data to work with. And in the real world, you would be asking several hundred respondents minimum for something like this. But for the sake of simplicity, I forced Drew to take this 20 times. So what I'd like to do is show what Drew looked at regarding each question. So there are 2 bikes side by side, and we alluded to this in the last video. So for instance, this is a $12,000 carbon fiber bike from Argon 18 with mechanical shifting, etc. And so Drew is forced to choose between these 2 bikes which one he prefers. And it is after he chooses this and we get several responses that we're able to analyze his implicit preferences in buying a bike. So what this data looks like, let me kind of show you. So this is a single response, and you'll notice you have 2 lines here. And the reason for that is, with this question, if he chose this bike, which I suspect he might, knowing how the analysis turned out, he chose this bike, but he did not choose this bike. So we actually gained 2 data points from this one question, and that's why you're seeing here a choice of one and the non-choice of the other, and along with the attributes. So this is an example of Drew's 20 responses. Actually, it's a curtailed list of them. So 20 questions equals 40 data points that we're going to work with. And so the question is then, what were the attributes that were most responsible for his choice, and which of his attributes are most responsible for his non-choice? And those are basically 2 sides of the same coin. So we're analyzing the whole coin here. So Drew, when you were taking this survey, what were some of the things that came to mind that you felt were more important for you in terms of preferences?
Yeah, it's a good question. So I would have guessed, I'm a climber, which is generally you want a lighter bike that's stiffer, so you're generating as much power to the ground as possible. So I tend to like carbon fiber bikes. They tend to be a little bit stiffer. So a lot of people don't like the feeling because it can be very jarring, but I do. So I would have thought carbon fiber construction. I would have thought a lighter bike that's stiff would have been my choices. I probably would have leaned towards the electronic shifting, as I've recently added that. It's totally unnecessary. An advertisement for any type of thing, but I got it and it's amazing.
Nice.
So unnecessary. So I would have thought I'd lean that way. So that'd be kind of where I would take, but I would probably have put like composition at the top, I think.
Awesome. Let's take a look at what actually happened. So I'm excluding price from this bar chart or this pie graph for a reason which I'll explain later. But it appears that even those 5 attributes were explained almost about half of what went into your choice. So the 3 big ones are in fact composition, weight, and riding experience. Brand contributed somewhat to choice, and there's a very, very, very small sliver here that which was the shifting that contributed a very minuscule amount of explanation to variance of your preferences. So we're going to walk through this starting from the most important factor down to the least important factor. So here we have just an example of the riding experience, and the way to read these graphs for the next 2 slides is that blue is anything that's statistically significant contributor to choice, orange is anything that's statistically significant contributor to non-choice, and then anything that's in gray is basically not statistically significant either way, but we can use it potentially for some directional guidance. Now keep in mind, we're only dealing with 40 data points here from one single individual. But yet it's very interesting that we may be able to tease out Drew's preferences even with such a short data set. So what we see here is that Drew actually does prefer the stiff and responsive bike much more so than the soft and comfortable bike, and it is statistically significant. What that means is that, give everything else equal, a stiff and responsive bike was chosen by Drew more often than not compared to the soft and comfortable. So that was the number 1 factor. Number 2 factor, which is right behind, is the weight. And so we see in general, we've got 18 pounds here, 16 to 18 pounds is 16 pounds or less. So we've got decreasing weight. And as you can see directionally, as the weight decreases, Drew prefers the bike more and more. Now, I can say that if the bike was 18 pounds, that was a statistically significant contributor to non-choice. But what I can't say is that if it was 16 pounds or less, that he statistically significantly preferred it. Now, again, we only have 40 data points here, but I think the pattern here is very clear and echoes exactly what you said, Drew, is that you do prefer a lighter bike.
Sure. And that's always, like I said in the last video, that's a huge challenge for me, is that some of these smaller guys, they can get bikes that are like 14 pounds, but mine are always a little bit heavier because they're so much larger. So,
exactly.
If I can get something that's 16 pounds or less in my size, that's pretty awesome.
Yep. And so that's echoed here, which is nice and fortunate. So Drew, let's throw it to you. So here we have the third most important factor to your choice, which is again very close to your number 1 and number 2, is composition. So what stands out here as what you empirically prefer?
Yeah, I mean, it looks like, as I suspected, if the bike was carbon fiber, then it was statistically significant.
Yep.
To me making that choice. Interestingly, because I really admire, there's a number of really cool handmade steel bikes from a lot of different small artisans that I always think are so beautiful. But it's interesting to see here that, from a directional guidance standpoint, it looks like that, I wouldn't necessarily lean towards picking those bikes if given my druthers.
Right. And the great thing here is when we go back to these 2 bikes is all of these were applied to each question randomly. And so given some of the constraints that we put in the last video. And so it's the analysis here is very straightforward. And what this means is that everything else equal, Drew does in fact prefer the carbon fiber bike, especially much more than the steel. So here are Drew's preferences to brand. Now, none of these are statistically significant, and we see in this pie chart here again that the brand was a minor contributor. But we do see some directional guidance that had we had more observations and Drew were to take this 50, 60, maybe 70 times, or if we had other respondents, that we would see an overarching preference to some brand. So I can't say that Drew prefers Giant or Argon 18 brands, and I can't say that Drew does not prefer Trek and Specialized brands, but I can kind of keep this in mind that there could be something forming in terms of his brand experience.
Yeah, that's interesting as well, because I tended to prefer smaller brands. Obviously, Giant is not a smaller brand. But,
yep.
That it's interesting to see this out. There's a funny joke in the cycling community that giant bikes are fantastic, especially at the high end, and they have world tour teams and things like that. But it's so many people are familiar with it as kind of like the first bike that anybody ever buys. That the joke is that Giant would be a lot cooler if they were called anything else.
Nice, nice. I like it. Actually, the funny thing is you could actually test that theory using a conjoint. Is make up some brands or even some other brands is finding out, where all else equal compared to the other characteristics of a bike, is Giant preferred or not preferred. And so, even independent of the bike's features, if you slap the Giant brand name on it compared to some other brand, you can actually test that hypothesis.
Well, that's very cool. You can see how this all works together.
And then the final one is shifting. So there is some directional indication that electronic shifting is preferred here, but it's not statistically significant. And given, such a small explanatory power to Drew's preference, I would not make many conclusions about this, and instead would rest on the fact that Drew's preferences is mainly driven by weight, by riding experience, and composition. Now, there's some other cool things we can do with conjoint analysis, and actually this is where things get even more powerful. So, for instance, I can pretty much guess Drew's perfect bike compared to Drew's not so perfect bike, at least with the information in the survey. Now, I can't guarantee that this is exactly correct because, again, we only have 40 data points here. But how did I do, Drew? Would you say that this would be one of your better bikes and then one of your not so preferred bikes?
Yeah, it's pretty funny because I think I mentioned as I was looking this over before the video that I was pretty blown away by how on point this is, and given the fact that you, Kevin, will say that you don't know anything about bikes, right? And
yeah, nothing.
The fact that you were able to put this together, it is pretty amazing, and I think the implications of being able to get this finite and that accurate of a picture, not knowing anything about the space, is really, really cool.
Yeah, it's pretty powerful, and you get this information very quickly because you're choosing one bike against the other, and that gets you so much information rather than taking a lengthy survey to understand what do you think about this, what do you think about that. So there's two more things I want to show here, and there's even more that we can do. So, there are certain things that Drew prefers in a bike and certain things that Drew does not prefer. And using the model, we can actually construct a situation where Drew would be equally likely to choose one of two bikes. And so let's assume any brand, any price, any weight, any shifting. Let's just assume it. You don't even have to matter. If one of those bikes was carbon fiber but with a comfortable ride, and the other bike was steel but a responsive ride, then I can actually statistically show that Drew is equally preferring of either bike. And so it gives you an idea of the trade-offs that we understand with what Drew's preferences are.
Very cool.
And the big one here is price. So just like we can trade off one attribute for the other, we can also trade off price, because price is also a variable in this model. And so, again, we only have 40 data points, so these estimates are squishy at best. But what I can start to dollarize and monetize what a carbon fiber bike means to Drew compared to a titanium by saying this: if I have a bike, everything else equal with brand, weight, shifting, etc., that's titanium, then Drew is equally as likely to choose a carbon fiber bike if it's $7,700 more. So in other words, Drew would be willing to pay $7,700 more for a carbon fiber bike relative to a titanium bike. If that carbon fiber bike was $5,000 more, then he'd be more likely to buy it. If that carbon fiber was $10,000 more, he would not be. But I can start monetizing what these attributes are worth, just like I can do this with weight as well, where he prefers the lighter bike, and I can actually show how much he prefers it. Now, again, it's not really the numbers that are important here as much as understanding that because we have price in the conjoint, we can actually start assigning dollar amounts to what each one of these items are worth, and therefore figure out what's truly valued by the respondents.
This is very cool and very scary, because obviously if my wife sees this video I spend on bikes, we're gonna have some trouble. But this is it's very, very interesting, and I think, like we said in the last video, it's very cool to see that this is the first video where we really used this powerful platform to showcase how we can derive, how we can make decisions based on the information that people give us, and even just a small amount of information yielded such an incredibly accurate result. That's so cool.
That's awesome. Thanks, Drew.
Well, thanks a lot, Kevin. Talk soon.